Alrighty, here we're going to take a look at example 7 and 8 on the application sheet. Number 7 says Joe has 7 coins in the piggy bank. All the coins are dimes and quarters. The value of the coins is $8.10. Find the number of dimes and quarters. So the first thing, much like we've talked about here on previous problems, we want to define our variables. We want to know what we're finding. We go to the question at the end. It says find the number of dimes. So we need the number of dimes and quarters that's in his piggy bank. So defining the variables is going to be as simple as just, all right, the number of dimes, the number of quarters. We're going to use D and Q. Those just seem to make a lot of sense to me for variables since we're talking about dimes and quarters. It's going back here and starting the rate equation. Says Joe has 42 coins. It also says the value is $8.10. Well, sometimes we talk about the idea that each sentence is its own equation. I don't know that that totally follows suit here, but this one I guess kind of would. The value of the coins is $8.10. I also look at themes, and in this I see a theme of money. So we're going to deal with our one equation with money. The other theme to me here is that he has 42 coins. And when we're talking about that, that is the number of. So let's start with that idea. He has 42 coins. This first equation, first theme dealing with the number of, when I add together all of his coins, the total number of coins is 42. So, well, what coins does he has? He has dimes and he has quarters. So D plus Q, or dimes plus quarters, is a total of 42 coins. The second equation is dealing with the value of his coins. Well, the value here is $8.10. Once again, $8.10 is a total. The value of the dimes and the value of the quarters. We've got background knowledge that we need to bring in here. We know that each dime is 10 cents. So I'm going to put 10, going to put my decimal point real low for a reason. 10 cents for every dime, plus we know that it's a quarter is 25 cents for each quarter. Now, I'm not a big fan of working with the decimal points, so I put them down here low so I can get rid of them. Basically, what we're going to do is we're going to multiply this equation through by 100. When you multiply by 100, the decimal moves twice, and basically the decimal is just going to go away. So multiply by 100, that decimal goes away. Multiply by 100, that decimal goes away. Multiply here by 100, the $8.10 now becomes 810. All right, we got a system set up. We want to eliminate in this case because they're both in standard form. I'm going to multiply my top equation through by negative 10, because when I multiply by negative 10, that is going to give me the same number with different signs in front of my variable of D. So when I multiply through by negative 10, I get negative 10D minus 10Q is equal to 420, and that is also negative. The other equation here just simply comes over. So 10D plus 25Q is equal to 810. Now, as we go through and solve this, we're going to eliminate the D's. So the negative 10D, the positive 10D, they eliminate, and that gives me nothing with the D's. The negative 10Q and the 25Q gives me 15Q. And when I put these together, negative 420 and positive 810 is 390. So to solve this, we're going to divide 15 on this side here as well. And Q, which represents the number of quarters, is going to end up being 26. So the number of quarters is 26. All right, we take that value for the number of quarters, we plug it into one of the original equations. I'm a really big fan of this first equation because there's no numbers to deal with multiplying here, so it's just going to be d plus 26, and that is equal to 42, and we subtract the 26 on each side, and we find out that our number of dimes in this case is equal to 16. So my final answer here, number of dimes is 16, number of quarters is 26. All right, let's take a look here at our next example. And let's see if we can find and create a little more room here to write. You have a coin collection containing this time nickels and dimes. You have 75 coins in the collection. You have $5.50. How many of each coin do you have? So, taking a look at defining the variables at the beginning here, just like we did in that last one, it's asking how many of each coin do we have? So these are going to help me define my variable, and the coins they're talking about are nickels and dimes. So we are going to talk about variables of n and d, n being the number of nickels and d being our number of dimes. Once again, in this, I'm looking at it and I'm seeing themes that are kind of coming to light here. One of the themes is talking about the number of coins. There are 75 coins in the collection. The other theme that I'm seeing that is appearing here is that we have $5.50. So one equation is going to be the theme of the number of. The other one is going to deal with the theme of the amount of, or the money. So here we go, the number of coins. The number of coins is 75. So the total number of coins is 75, and it's what's in the collection, or nickels and dimes. So it's going to be n, the number of nickels, plus d, the number of dimes. The total number of coins added together is equal to 75. The next equation, once again, $5.50. That is the value of the collection. So $5.50. And what's adding to the value of this $5.50 as well, it's every nickel and every dime. Well, there's 5 cents. We know the value of the nickel is 0.05. So we got to bring this background knowledge in of the value of a nickel. And don't forget, it is 0.05 and not 0.5, because 0.5 or 0.50 would be 50 cents. Plus the value of a dime is 10 cents, so it's 10 cents for every dime. So 5 cents for every nickel, plus 10 cents for every dime, and I have a total of $5.50. Once again, I'm not a real big fan here of the decimal point, so if we multiply through by 100, multiply through by 100, we are going to end up with 5n plus 10d is equal to 550. Multiplying through by the 100 makes everything, every decimal move 2 places to the right. Now I'm going to go ahead here and multiply through my first equation by a -5. And as we multiply through by -5, that is going to make so that the nickels have the same number in front and also different signs, so I can eliminate, because when we're in standard form, typically the easiest way to solve is elimination. So -5n, -5 times d is -5d, and that is equal to 75. The next equation is just going to come over as is. 5n is going to eliminate with the -5n here in just a moment, plus the 10d is going to come down, and that's equal to 550. A little mistake here we made. We need to multiply That's actually a common mistake that sometimes student makes, so that's probably a good thing that I did that even. I can't forget I got to multiply that -5 also times the 75, and when I do that, I get a -375. All right, so we're now set up, and the n's, well, they eliminate because -5n, +5n. -5d plus 10d is 5d, and that is equal to, well, 550 and the -375 is going to be 175. We divide each side here by 5. And when we do that, the number of dimes is going to be equal to 35. All right, well, we've got the number of dimes. Go back in, plug in to get the number of nickels. So here we go, n plus d, well, the number of dimes is 35, equal to 75 using that first equation because that's really easy to work with without any coefficients in front of my variables there. So we subtract the 35 on each side, and we find out in this problem that the number of nickels ends up being 40. So my final answer here, the number of nickels is 40, and the number of dimes being 35.